right, welcome to lecture 5.2. So now we are looking at the trigonometric functions. So before we were using the different x and y points on the unit circle, and now we're going to use those with something that are the trigonometric functions. So these are some definitions on the values we get from the unit circle. And for that, we're going to use this. So, toa. You might have heard this before. Basically, this is helping us define some of the functions that we have from the unit circle. Now, let's see. So S is talking about sine. Okay, that's going to be the function called sine. C stands for the function we'll call cosine. And T stands for the function that is going to be called tangent. Now, there are three other functions, but they fall directly from these three. So we're going to take a look at just these three and where they come from. Now, you'll notice each of them has attached to them two other letters, and that helps us define what these are. So we're going to define them from the unit circle. Now, what is this talking about? Well, real quick, I'm going to go ahead and make sure. So we're talking about sine of t, cosine of t, and tangent of t. Okay, so where t is some angle on the circle. So let's say I have drawn my radius here. And remember, what's our radius for this circle? The radius is 1. And we have some t value. And then on this, we can draw, remember, that right angle. And that's where we use the Pythagorean theorem, x squared plus y squared equals 1. All right, now from this, we're going to take a look at our angle T. And we're going to label it opposite, hypotenuse, and adjacent. What does that mean? Well, real quick, I'm going to head and move this. So the hypotenuse for our triangle is the radius, which was 1, remember? So h is our hypotenuse, which is equal to 1. Now, O stands for opposite. Ooh, let me change that. Okay. O stands for opposite, and that's this side right here. And remember, we're talking about the angle or the side directly across from T. Okay. So O stands for opposite, and then the last thing we have here, besides O and H, is A. And A stands for adjacent. That is talking about the length adjacent to T. Right there. Okay, so now we have discussed at least all of those. Let me go ahead and color code these. Let's go ahead. And then H. Awesome. Okay. Now we're going to use this with a triangle to define these three functions. Okay, so let's see. But first off, before we do that, this point up here, we're going to call it x, y. It's some random point, which basically means this distance here is y, and this distance down here is x. All right, now let's go ahead and define sine and cosine. So first, let's start with sine. Sine of t. Well, according to our directions here, sine is OH. What does that mean? That means opposite over hypotenuse. It always starts the first letter over the second letter. So we have opposite over hypotenuse. Well, what is the opposite from T? So across from T, we have Y. Remember, we're talking about T from the angle in our triangle right here. We're talking about this T right there. So that's Y over, and then the hypotenuse is, it's just 1. Remember, the hypotenuse is the radius of our triangle, and the radius of our unit circle is always 1. So that's going to be over 1. Well, that means that sine is equal to y. So let's write this out on the sine side a little clearer. Sine of t is equal to y. Now let's figure out cosine. So cosine of t, what do our directions say for SOHCAHTOA? It says adjacent over hypotenuse. So adjacent over hypotenuse. Well, what is the adjacent value? That was the x value, the green value. So that was the adjacent. So that's going to be x over, oh, and once again it's over hypotenuse, which we said before was 1. So hypotenuse is 1. And that simplifies to x. Awesome. Okay, so cosine of t is equal to x. Next and lastly, at least for these, for this example, we're going to look at tangent. What is tangent? Well, by the definition, and remember, SOHCAHTOA is just shorthand for the definition of these three functions. So tangent is supposed to be the opposite over adjacent. Well, let's see, what is the opposite? The opposite is y. And the adjacent is a, which is supposed to actually be the x value. Sorry about that. So opposite value is the y length, adjacent value is the x length on our little triangle here that we're looking at, which means that tangent is equal to y over x, and that doesn't simplify. So we have tangent of x, or tangent of t, sorry, is y over x. And here we have the three sort of main functions that we're looking at that we draw from the unit circle. Awesome, so now let's go ahead and take a look at all 6 of these. So pretty much the other 3 that we're going to look at come directly from the 3 that we just found. So once again, let's take a look at the ones we know. We know sine of t is equal to y, cosine of t is equal to x, and tangent of t is equal to y over x. And please note, x cannot equal 0. And that makes sense, right? Because x is in the denominator, and we can't let anything in the denominator be equal to 0. Now, for functions, remember we always look at, or we don't always, but we can look at the reciprocals of those functions. And that's what we do here. So for sine of t, the reciprocal of sine, which we call cosecant, okay, so this CSC here is cosecant. So cosecant of t is the reciprocal, so 1 over y. And in this case, please note y cannot equal 0 because it's a fraction. Next, let's look at the reciprocal of cosine. So the reciprocal of cosine is called secant of t. And once again, that's the reciprocal, where x cannot equal 0 this time. And the last reciprocal we'll look at is cotangent. That is the reciprocal of tangent, which is basically you just flip the x and the y. And this time, y cannot equal 0. Okay, so just note that here for this one, we just take the reciprocal. So as usual, these 3 down the bottom are the reciprocal. Whew, forgot how to spell that for a second. All right. Now, what are we going to do? Well, we're going to find all 6 trigonometric functions for t equals negative pi over 6. What does that mean? Well, here are our 6 trig functions, and we're going to find those values. So let's see. I'll just go ahead and start with sine and go along the way. So sine of t, and in this case, we're saying that t is equal to negative pi over 6. Okay, so that means sine of negative pi over 6 is going to equal y. Well, I need to figure out what x and y are at this, the t value of pi over 6. So let's take a look at our unit circle real quick to figure this out. Where is negative pi over 6? Well, remember, when we have a negative, that means we're going to start in the opposite direction. So we're going to start in this direction and move pi over 6 values. So pi over 6 values, it's actually not going to be quite that far. It's just going to be a wee bit down. My pen is slightly loading, sorry. Taking a small moment to glitch here. Okay, there we go. So pi over 6 is about here. And the negative value. So remember, once again, once you know the 3 coordinates up here, so we have root 3 over 2 half, root 2 over 2, root 2 over 2, and then, ooh, this one I'm going to squeeze over here. that is 1/2 root 3 over 2. So once we know these, we just have those memorized and remember where the different coordinates are negative. So down here in quadrant 4, the y values are negative, which means our point here for pi over 6, or negative pi over 6 in our case, is going to be root 3 over 2 negative half, because this is the original pi over 6. Okay, so the original pi over 6, I'm going to highlight in, oops, no, let's not do green. In red, that's the original one, but remember we went down. So we have the negative pi over 6, which is going to be this point here. Aha, so the coordinate points we're working with, x, y, are going to be equal to root 3 over 2 negative half. Awesome, so we found our x and y values, and now we can use that to find the rest of our trig functions. So since sine of negative pi over 6 is equal to y, we'll just take a look at our y value, and our y value is negative 1 over 2. So sine of negative pi over 6 is equal to negative 1/2. Awesome. Okay, just 5 more to go. Next, let's take a look at cosine of, and in this case, t is equal to pi over 6, and negative pi over 6. Well, cosine is just equal to the x value, which means it's just going to be right there, the root 3 over 2. Not too bad. Okay, so next we're going to take a look at tangent t. So we're doing the 3 main ones first, and then we'll take a look at the reciprocals. So tangent of t is going to equal, according to our definition and what we found earlier, y over x. So tangent of, and in this case, t is negative pi over 6. So it's going to be equal to y over x. And we've already found both y and x, so that'll equal y is equal to negative half, and x is equal to root 3 over 2. Darn, we can't leave it that way. That is a complex fraction. So because we can't leave it that way, we have to do some simplifying. Well, the 2's cancel out, so that's awesome. Let me go ahead and indicate where I'm going here. Okay, let's keep solving there. So that's equal to negative 1 over root 3. I'd like to be done, but we're not. Why are we not done? Because we have that root 3 in the denominator. We cannot have radicals in the denominator, which means we need to rationalize it. So to rationalize, we'll go ahead and multiply it by another root 3. That'll go ahead and cancel. And if you're not sure why this cancels, this is a skill from previous classes. But go ahead, send me an email, and I'll send you some resources on working with rationalizing denominators. Okay, so rationalizing that, we'll end up with negative root 3 over 3 is equal to tangent of pi over 6. I'll go ahead and box that so you can figure out where that is. Awesome. So we have the main 3. Let's go ahead and find the other 3. So the reciprocal of sine is cosecant, and that's going to be 1 over y. Or another way to look at it is to just take the reciprocal. So let's take the reciprocal, which is going to basically be negative 2. So there's 2 ways to do it. One, you could plug in the value of the negative half down here and go ahead and solve. Or you can just take the reciprocal of sine if you happen to have sine, which usually is a little easier. Next, we'll go ahead and find secant. So secant is going to be the reciprocal of cosine. Ooh, and we have that radical. Okay, so the reciprocal of that is going to be 2 over root 3. We can't have that radical in the denominator, so let's go ahead and rationalize. Multiplying by the root 3's, and we'll end up with 2 root 3 over 3. And I'm going to go ahead and box this just because I have some extra work, just so I can be clear about where my work is. Now lastly, cotangent. Ooh, and I noticed I was doing something wrong here. I don't know if you caught it. I should be inputting pi over 6, that negative pi over 6. Let me go ahead and fix that. Okay, so negative pi over 6, negative pi over 6, and then cotangent of negative pi over 6. All right, so cotangent, that is going to be the reciprocal this. Now, we could use a little different version here. We could either take the reverse or the reciprocal of tangent, or maybe I'll use the formula this time. So I'm doing a different method than I did with these two. So this time I'm going to follow the directions up here, which is x over y. Now, x is root 3 over 2, and y is negative half. I'll go ahead and cancel the 2's, and we have negative root 3. Now you might say, well, why do you choose a different method this time instead of following the same methods before? The reason is, if you notice tangent right here, if I took the reciprocal of that, I would get a radical in the denominator, and I would have to rationalize all over again. So I decided I would try the other method, and I think it worked out a little better. I didn't have to do any rationalizing. So once again, two methods. Now let's take a look at something important. This is the domains of trigonometric functions. So for sine and cosine, the domain is all real numbers. Now for tangent and secant, it's all real numbers except for pi over 2 plus n pi for any integer n. A little confusing, but the basic thing is, for tangent and secant, they both have x in the denominator. Okay, that means that there's a point when it's undefined, because you cannot let 0 be in the denominator. So for whatever that value is in the denominator, you have to take that out of their domain. And then for cotangent and cosecant, what do they have in their denominators? They have y in their denominators. Okay, I'm going to go ahead and write that down. They have y in denom, and this says x in denom. Okay. So we use the fancy terms of pi over 2 plus pi over n. That's because at times the value you have inside where t is might be a little more complicated. But the basic thing to remember at this point, we'll take a look at it further in the course, but it's because they are the reciprocals and they have a variable in the denominator. And because of that, that variable could be 0 and we can't let that happen. So the only two that have all real numbers for their domain are sine and cosine. Now let's take a look at example 2, finding the value of the function. All right, so this is pretty similar to what we did before. And we're taking a look at, let's see, sine, cosine, and tangent. So the three main ones. And they're all talking about 5 pi over 6. So we have t is 5 pi over 6. I want to figure out what that is in order to find sine, cosine, and tangent. So let's go take a look at our unit circle and figure out what that value is. Now you might already have it memorized by now, and that's awesome. If not, you do need to end up drawing the unit circle. So 5 pi over 6 is smaller than 6 pi over 6, and that would equal pi. So we know it's basically over here. That's 5 pi over 6. And we know the original pi over 6, the coordinates for that are root 3 over 2 half, which means the coordinates for 5 pi over 6 are root 3 over 2 half, but the x value is negative. Let me squeeze that in. Okay, so we found our value. xy for 5 pi over 6 is going to be root 3 over 2 half. And sorry if the noise or the sound in this video isn't the greatest quality. My headset is currently not with me. So hopefully from my other videos, I'll have better quality on the sound. All right, so sine. Well, we know that sine of a value is supposed to be the y, right? Sine of t is equal to y. Well, what's the y value for a coordinate? It's half. There we go. Sine of 5 pi over 6 is half. Now cosine. Cosine is the x value. So cosine of 5 pi over 6 is going to equal the x value, which is negative root 3 over 2. And lastly, tangent. So tangent of 5 pi over 6, if you recall, tangent is defined as y over x. So y over x is going to be 1/2 over negative root 3 over 2. Ooh, we have that radical appearing in the denominator again. Let's go ahead and simplify the complex fraction there. And we'll have 1 over negative root 3. We need to rationalize that. Multiplying by the root 3 to rationalize, we'll end up with root 3 over negative 3. And you can move the negative up to the top with that 3. And then that's what we'll have for tangent 5 pi over 6. So once again, remember, you always need to rationalize. We cannot leave that radical in the denominator. Okay, if you don't need to rationalize, the directions will tell you. Other than that, assume you need to rationalize. So, one thing that we look at in Math 135, or that we introduce, is even and odd functions. And that has to do when you input a negative value, do you get the same function or the opposite of the function? So that's something we did in 135, so we're just sort of continuing with that concept in 140. Now, the even functions are cosine and secant. And then the odd functions are anything that have to do with sine, is the way I remember it. So sine is odd, and cosecant is the reciprocal of sine, so that's also odd. Tangent, remember tangent is y over x, which means it includes sine, so that's also going to be odd. And then cotangent is x over y. Let me go ahead and write that down. So they all include sine, which is y. And because sine is odd, all the rest of these guys are odd. At least that's the way I use to memorize this. Okay, so anything that includes just the x, anything that just includes the x is going to be the even functions. Now, using that in mind, let's go ahead and evaluate the following functions. So the same concept here from what we just did in example 2, except we have those negatives floating around on the inside. Okay, and as usual, whenever we see the negatives, we just take a pause and think about what we're doing. So sine. We have that negative. What do our directions say? Well, since sine is an odd function, when we simplify, it's going to be the negative of sine, or the opposite of sine. So this is just going to be the opposite of sine of 5 pi over 6. Well, we already found out what 5 pi over 6 was, didn't we? It was a half. So right up there. So that's going to be negative half. Now, for cosine. Well, we know cosine's even, which means this simplified is just going to be the positive. 5 pi over 6. So we already found cosine of 5 pi over 6 right up there. We're not going to do anything to change it. It's just going to be negative root 3 over 2. Now for tangent. Tangent, is that an odd or an even function? Well, it has to do, if you remember, with y, which means it's going to be an odd function. So we'll go ahead and pull out that negative, and that'll be 5 pi over 6. So the opposite of tangent of 5 pi over 6, which we found earlier, right up here, was negative root 3 over 3. So that's negative of negative root 3 over 3. And we can simplify that to root 3 over 3. And there we have when we're working with the negative values inside of our function. So just bear in mind, anything that uses y is going to be the odd. Anything that just uses x will be an even function. All right, moving along. Let's go ahead to example 4. Here we are going to determine if the function is even, odd, or neither. So note, cosine squared x is the exact same thing as cosine x squared, and cosine x squared is the same as cosine x squared. Okay? So a little different on where the squaring is. If the square is in front of the x, we're talking about the whole value squared. And if the square is after the x, we're talking about literally just the value inside with the x. Okay, so small difference there, but it will be a big difference later on. So just definitely study this for a second. All right, let's take a look at sine x equals cosine squared x. Well, what do we know? So to determine if it's even, odd, or neither, the test is to always input the negative x value. That's the test. And if, when we input the negative x value and we end up with f of x, the function is even. I don't know why I drew an O there. Even. If, when we put in that negative x and we end up with the opposite of f of x, the function is considered odd. If, when we input negative x and we don't get the opposite of f of x or f of x itself, it is considered neither. So if it's not exactly the opposite and it's not the exact same thing, it's considered neither. Let's go ahead with the testing. So we're inputting that negative x, so we have sine of negative x, cosine squared of negative x. So sine of negative x, well, we know that when we have that negative, we have to pull it out because sine is an odd function. So that'll be negative sine of x. Now cosine squared of negative x, let's simplify that. We know that cosine squared of negative x is the same as that. So that'll be cosine of negative x squared. And we know that cosine is an even function. So the negative doesn't come out. So it's just going to be positive. So that'll be sine of x, and that'll be cosine x squared, or we could do cosine squared x. Now, what do we have here? We have negative sine of x, cosine squared x, which is basically the exact opposite of what we have up here. So we have the opposite of f of x, which equals negative sine x cosine squared of x. So since we have the exact opposite, this means our function is odd. So f of x equals sine x cosine squared x is odd. Okay, and all this testing right here was something we went over in 135. Once again, if you need a refresher, just send me an email. And I'll try to get some resources to you. Now we have something else we're working with. It's called the reciprocal identities. It may look like a whole ton, but basically it draws exactly from what we use up here. Let me go ahead and move up here. It draws exactly from this. Okay. How do we know that? Well, if you recall, cosecant, I'm going to erase this in a second. So cosecant of t is equal to 1 over y. That's what we learned earlier. But if you also recall, sine t is equal to y. So all we've done with this for the identities is we said, well, if y equals sine t, we can just go ahead and just substitute that in. So we know that cosecant of t is equal to 1 over sine t. Okay, so that's just the way they did it right here. And then let me go ahead and show you one other one. And if you want to play around and find the others, you can totally do that. Let's see, what's another one we'll work with? Well, let's show you one of the more complicated ones. So let's go ahead and prove this one. First off, we know, remember for the unit circle, that that y squared plus x squared equals 1. That was for the unit circle. That comes from the Pythagorean theorem. Because we're talking about, remember on a circle, we have that right triangle. Ooh, that was a nasty looking, let me erase that. Radius 1, that's what we're talking about. But remember, y is the same as sine. So this is sine squared of t. Plus, and x is the same as cosine. Equals 1. So right there, I just figured out where that one comes from. Let's go ahead and move on and find the other one. So now to find the other one, how will we do this? Well, we're going to be sneaky. Let's go ahead and divide all of them by cosine squared of t. Now what do we get when we divide by cosine squared of t? Well, and remember this is not example 5, this is just some side scratch work. So sine, if you recall, is x, and cosine, if you recall, is y. So this is xy squared, which is basically going to be when we have, oh sorry, I wrote that wrong. That's supposed to be y over x. Sine is y, not x. So that's going to be y over x squared. And y over x squared is going to be tangent. So that's tangent squared of t plus. Now for this value, anything divided by itself is 1. 1 equals, and 1 over cosine squared t. Well, that's the same as 1 over x squared. And 1 over x, if you recall, was the reciprocal of cosine, which is secant. So this will be secant squared t. And there we have proved the other identity. So you can go ahead and play around with all of these and see if you can prove that next one for fun. You never know, that might be an extra credit problem on an exam. Okay, so that's kind of where we prove where the identities come from. Let's go ahead and use them. So for example 5, we're going to write tangent of t in terms of sine of t, where t is in quadrant 3. Well, how should we do this? Let's start with what we know, and we want to start with tangent of t. So tangent of t, what does that equal? Well, tangent, if you recall, is y over x. So that's going to be sine of t over cosine of t. We're not done though, because we need to write it in terms of sine. And at the moment, we have a cosine in the problem, which is a problem. We just want to write it in terms of sine. So we need to find a way, using our identities, and this is where they come in handy, we're going to try to use these to see if we can swap out cosine and replace it with sine. Let's see, do we use any of these that have a sine and a cosine in it? Which one of these identities have sine and cosine? The top ones, well, this one has sine and cosine, but it also has cotangent, so I don't want to use that. Let's see, sine and cosine, sine and cosine, sine and cosine. Ah, the one that just has sine and cosine is this one right here. So we're going to go ahead and use that identity. Let's go ahead and do some side work. So sine squared of t plus cosine squared of t equals 1. Now what do we want to do? We're going to solve for cosine. Once we found that, we can sub it into our problem. So solving for cosine, we'll go ahead and subtract sine from both sides, so we'll end up with 1 minus sine squared of t. We don't have cosine quite yet. We need to square root both sides. And when we do that, important, remember that plus or minus. As usual, that is important. Okay, awesome. So now we have cosine of t equals plus or minus the square root of 1 minus sine squared t. I have a problem though. Should I use the positive or the negative? Well, let's look at what else they gave us. They said t is in quadrant 3. Now in quadrant 3, what do we know? We know that down here it's negative x and negative y, which means that cosine is negative. So I'll go ahead and take the negative value. Now we can do the swap. Okay, let's go ahead and swap these out. And we have tangent of t is going to equal sine of t divided by negative root 1 minus sine squared t. Okay, so you might be asked to rationalize this, and if you were, you could go ahead and do that. Right now we're going to pause with the rationalizing. Just wanted to show you this part, so we're not going to rationalize for this problem. And there we have our answer. If we were going to rationalize, however, we would need to use the square root of 1 minus sine squared x to rationalize. Sorry, sine squared of t. But we're not going to do that for now. So let's move on to example 6. Find the values of the trig functions from the given information. Okay, so we're only told one of the trig functions. Secant of t equals 5 over 2. And then we're told that sine of t is less than 0. So that's all we know. We're going to have to piece this together using the identities and anything else we know. So let's see. So secant of t is 5 over 2. What is secant connected to? If you recall, secant is the reciprocal of cosine. So we can find cosine using this. So cosine of t is going to equal the reciprocal of this. So that's going to be 2 over 5. Now we need to figure out a way to find the other 4 functions. Let's see, can I use any of my identities? Well, I knew that secant was 1 over cosine, so I've done that. Now can we use them or any of the other identities? I only have secant and cosine, so I need to figure out the other ones. Let's go ahead and use the bottom identity again, so the sine squared t plus cosine squared t. We can use that to find sine, because we already have cosine. So we already have cosine, and when we use this, we can solve for sine, and then we'll have one more of our functions. So let's go ahead and do that. So sine squared of t plus cosine squared t is going to equal 1, and we already know. Actually, I'm going to move this to the side so I have more space. Cosine of t equals 2/5. So I already know that cosine of t is equal to 2/5. So let's go ahead and plug that into our identity. And I'm going to write what I'm doing. So if you ever have a lot of work going on, just write what you're doing right above it so I know what you're doing. So solving for sine of t. Let's go ahead and plug in our cosine value, so 2 over 5 squared equal to 1. Okay, so sine squared of t plus, and that'll be 4 over 25 equals 1. Let's go ahead and subtract 4 over 25 from both sides, and we'll get sine squared of t equals 1 minus 4 over 25. Okay, to do the subtraction, we need to create the same denominator. So 1 will become 25 over 25. Once again, if you need a refresher on fractions, just let me know. Then we have sine squared t equals 25 minus 4, so it'll be 21 over 25. We're not done yet. We need to get sine, not sine squared. So square rooting both sides, plus or minus. And we're almost done. Which one do we take, the positive or the negative? And how do we know? Well, if you notice in the beginning, they told us sine should be negative, so we're going to take that negative value. So we'll take sine of t equal to the negative root 21 over 25. Ooh, I jumped the gun a little bit. I forgot to simplify that before I finished. Let me back up real quick. Let's simplify this, and then we know we're going to take the negative. So sine of t is going to equal plus or minus, and that'll be square root of 21 over, now the square root of 25 is just 5. And we can't simplify the square root of 21. So now we can take our answer. So take sine of t equal to negative 21 over 5. So sine of t, we found 3 so far. Awesome, we're halfway there. Now we need to figure out how to find the other 3. Well, if you recall, what do we know about cosecant? Cosecant is the reciprocal of sine. Let's go ahead and do that. We'll take the reciprocal of sine. So cosecant of t is going to equal the reciprocal of 21 over 5. So that'll equal negative 5 over root 21, which we need to simplify because remember we can't have that radical. So rationalizing, we'll get negative 5 root 21 over 21, which we cannot simplify. Ooh, we have 4. So now we just need 2 more. We need tangent and cotangent. Now, if you can recall, tangent is sine divided by cosine, which we can find. So tangent of t is going to equal sine, which we had was negative root 21 over 5, divided by cosine, which was 2 over 5. And the 5's can cancel, and we're left with negative root 21 over 2. And we found tangent. Whew, we're almost there. We have 1 more, and that's cotangent. So cotangent of t. That is supposed to be the reciprocal of tangent. Or we could just do x over y. Either one, we're going to end up with a radical in the denominator. So Let's go ahead and just take the reciprocal of tangent this time, so a little differently than I did last time. That'll be negative 2 over 21. Once again, we cannot have that radical, so let's go ahead and rationalize. And we're left with negative 2 root 21 over 21. And that also cannot simplify. So we have found all of our values. Let me go ahead and box the ones that have a little more work so they're easier to see. And I'll just box them all, why not? I usually only box if the work is very complicated and messy, which it was getting a little messy later. So right here we have our answers for example 6. And if you want to work on any practice problems, you can. These are not required for the summer session. So that is it for this video. If you have any questions, feel free to send me an email.